This is Business 3502 and another example for our textbook questions. Revisiting Chapter 8, this is question number 18, and we're given some information in this question. First, consider two portfolios based on the markets. Portfolio A has expected return of 12% and a beta of 1.2. Portfolio F has an expected return of 6% and beta is 0. And it goes on to say in the question, consider another portfolio, well diversified, that has beta of 0.6 and expected return of 8%. So we could add this to our chart. The question asked, would an arbitrage strategy exist? Okay, well, some things to take out of the information that's given. First, the portfolio with beta equals 0 must be risk-free. Because it has no volatility, no change. So this would be the risk-free asset in our equations. Second, let's calculate the return to beta for the potential portfolios. So for portfolio A, return to beta is, or excess return, and our market return for portfolio A is 12%, but we're concerned with excess return, and logic tells us that the zero beta portfolio is the risk-free. Okay, and then for portfolio A, it's beta 1.2. Okay, so let's just calculate that quickly. We can get a place without glare. Okay. 0.12 minus 0.06 is 0.06 over 1.2. So portfolio A, excess return to beta is 0.05. For portfolio B, excess return, again, divided by its beta, and we're told for portfolio B 0.08 minus 0.06 and beta 0.6. Obviously a less risky return, but promising less in expected return outcomes. So 0.08 minus 0.06, 0.02 of course, divided by divided by 0.6 is 0.03. And I guess we could show more decimals to that. This tells us portfolio A has much greater return for riskiness than portfolio B. So an opportunity for arbitrage would truly exist. Now, then it goes, we're asked what would be an arbitrage strategy? And we could consider equally weighted portfolios of A and B, or portfolios with A and F. Just tidy some things up here. Pardon. So continuing with camera back up. So we're asked then with the different portfolios, is it possible to create a new portfolio that will have better return for risk and may then lead to an arbitrage opportunity? So what our answer suggests is let's create portfolio G, and for portfolio G we'll use 50% of portfolio A and 50% of portfolio F, or the risk-free rate. Okay. So this will give us our expected return then on F is going to be 0.5 times the expected return on portfolio A, 1 to 12%, plus 0.5 times the expected return on F, or the risk-free rate, 0.06. And this is 0.5 times 0.12, 0.06, plus 0.5 times 0.06, 0.09, or 9%. And then beta for portfolio F is also going to be 50% times beta for portfolio A and 50% times beta for the risk-free rate, which is 0. 0.5 is 0.6. So now we have for portfolio G, we have the expected return of 9% and beta 0.6. And how does that look to portfolio B? If we can see this, portfolio B had beta of 0.6, that's the same. Portfolio B had expected return of 9%, or sorry, of 8%. Now we have expected return of 9%, so 1% pickup. And we could also do then a measure expected return or excess return to beta for portfolio F, or sorry, portfolio G, and that would give us 0.09 minus 0.06 divided by 0.60. So 0.03 divided by 0.6. 0.3 divided by that wouldn't be correct. 0.03 divided by 0.6 is 0.05. On our previous portfolio A had 0.05, portfolio B had our excess return to beta of 0.03, and portfolio G equals 0.4 portfolio A, or is superior to portfolio B. And in the end, key part, portfolio G is greater than the, let's say ER for portfolio G is greater than expected return for portfolio B, where 9% 9% expected return is superior to 8% return, or 1% better. So definitely an arbitrage opportunity exists, and we should definitely take that. By looking at return to risk for the two portfolios, we can select which portfolio is better, and depending on our level of risk aversion, we may actually wish to be short portfolio B and add more into portfolio A because it has a positive yield pickup. Finishing question 18.